Okay. So this is yesterday's inside 7 squares. And there was just a couple different ways to do it. Okay, so I just wanted to show you guys the different ways. There shouldn't be talking right now. Okay, so we're going to start with, I like the fact that you could just fold it in on itself. So I gave this as a hint for a lot of people. You could fold these in so we know each of these is worth 1/4. So this bigger one, you can fit 2 of the little triangles in there. So this one would be worth 1/2. And then you can fit 2 of those triangles in here, so this whole thing would be worth 1. You can fit 2 of those triangles in here, so it'd be 2. You can fit 2 of those triangles in here, so it'd be 4. Fit 2 of those, so it'd be 8. And then 8 plus 8 plus 8 plus 8 is 32. So this was all done with like seeing how many could fit inside of it, knowing that this is equal to 1, so each part would be 1/4. Okay, so that's one way. All right, this is another way where we would use kind of like Pythagorean theorem to figure it out. So we know this bottom part here is 1. So this is like one of those little triangles, but like blown up. Okay, so it's like this little triangle right there. This bottom is 1. I know these two sides have to be the same length. So this is the Pythagorean theorem, you know, a squared plus b squared equals c squared. So it's x squared plus x squared equals 1 squared. So 2x squared equals 1. Divide both sides by 2. So x squared equals 1/2. Take the square root of it. So I would get this one little side would be the square root of 1/2. Just that side. So I want 2 of them to give me that side, and so I would keep going up until I found this. I still get the same answer, 32. It just takes a lot longer because you keep having to do the Pythagorean theorem this way where you don't know what these sides are. Okay? This is almost exactly the same way, but I did want to say that I've had people take this and make a like grid and kind of estimate from the grid. They're like, okay, every square is this big, so how many can fit in there? And you do get approximately 8. If you measure this carefully and put it on here, you end up making a grid that's about that size. And you can figure it out. You just have to do the like a lot of little halves, that kind of a thing, to be able to do it. And this is, there's one on here where it was, I don't have it great, but it was of 45, 45, 90 triangle, so it's similar. So if this is 1, we know 45, 45, 90 triangles are square root 2 as big. So you have to divide by the square root of 2 to figure it out. And you can do it a similar way. I like the fold one the best. I think it makes the most sense. But I made you do this activity not because I thought all of you would get the right answer, but to get you guys to work in groups together and see how that goes, and to try something that you might not know how to do. But I feel like it's fair if I give you a problem, I better tell you what the answer is. Okay, you need to have your notebook out in front of you, and we are going to take a few notes on this. Okay. So we're going to do for today, we're going to call it 9/6. And I like to call this definitions of geometry. Okay. Do I need to zoom in a little?
Yeah.
Okay. The first one we're going to talk about is point. A point is a dimension. It's dimensionless, excuse me. It's a location. We talk about a point, we'll go like point A. So if I go 0, 4 on the coordinate scale, that's just a location. That doesn't give me a length, a width, a height, nothing. It's just a point. Line. Just length. One dimension. Okay, we often will write it, we've got M, or we've got N, or we've got L. Okay, we would call this a horizontal line. This would be a vertical line. And this would be considered an oblique line. Okay? And when we talk about a line in like written form, where we're not like drawing a picture, you'll see a little N and you'll see 2 arrows on the top. That means a line. It goes on and on forever. You can't just put a line on top of it without the arrows, because that means it's a segment. So we're going to talk about that next segment. It's still just a length. One dimension. But it has a starting point and an ending point. Okay, here's an example. Okay, that would be, we would call it segment CD. Draw a little line on top. Next we have ray. A ray, again, is just length. Still just one dimension. Okay. And it just has a starting point. We can still call it, you know, AB. And we would go AB, and it would have a starting point with a line over it. You don't really have to have the little point at the beginning. You could just go like this. Just the arrows on one side. Next we got a plane. It's 2 dimensions. And it's just like an area of space. Okay. When we talk about something as coplanar, it's on the same plane. Okay, so like the whiteboard over behind Jen is on the same plane as the Women of Math poster, okay, because they're on that wall, right? If we look at the ceiling, the lines in the ceiling are on the same plane, okay? So it's on that same area, flat space. Okay, we've got, what is an angle? An angle is made up of two rays. So if I've got my angle, I've got two rays going out. I've got A, B. The lag time is just like not long enough. There we go. There we go. It's going to be fun for people watching at home. Let's see. Okay. There are different parts. I'm moving this. There are different parts. We've got vertex. That's A right there. Vertex. It is a shared point of the two rays. Okay. And then we've got the sides. The rays make up at the angle. Okay, so oftentimes we do this to talk about an angle. And I can say BAC, or I can say CAB. Notice A has to be in the middle. Okay, when I talk about it, A has to be in the middle. Vertex, always in the middle. Okay, now we're going to talk about some things with lines that is going to be on your homework tonight. Okay, we're going to talk about intersecting lines first. Intersecting lines. Lines that cross at a point. It looks like this. And we call this like angle 1, 2, 3, and 4. Okay. Now, vertical angles have a shared vertex. But no shared sides. I think I'm spelling shared incorrectly. Sorry, guys. That word is supposed to be shared. Looks like I'm spelling shard. There's supposed to be an E here. Nobody's answering. They're just, whatever, Miss Murphy, we know what it says. Okay. All right, so vertical angles for this picture right here would be angle 1 and angle 3, angle 2, and angle 4. And vertical angles are equal. Now we're going to talk about adjacent angles. You guys want to know how many we have left? We have 3 in one example. Okay. Adjacent angles are next to each other. They have a common vertex. And a common side. Okay, so some adjacent angles for here would be angle 2 and angle 3, angle 4 and angle 1, angle 3 and angle 4, angle 1, and angle 2. Two more. We've got a linear pair. Two angles that are adjacent and form a straight line. And I had to switch pages, so instead of using that same example again, I'm just going to draw the picture right next to it. And we'll just label this like 6 and 7. That's a linear pair. Forms that straight line. Everybody got adjacent? Moving it away. Okay. And then, okay. Supplementary. I know. There's a lot at the beginning. Two angles that sum 180 degrees. Okay, so a lot of linear pairs are always supplementary. They add up to 180. So like 90 degrees and 90 degrees, that's supplementary. That equals 180, right? 80 and 100, that equals 180. Those are all supplementary angles. Okay, last thing. Want to do an example from your homework? And then we will not get to what I want to get to, but we'll do other things. Okay. So if I tell you this is 40 degrees right here, this is angle B, A, C. I want to know what angle A is, what angle B is, and what angle C is. Okay. So we just learned new things. If this is 40 degrees, is there any other thing up here that is 40 degrees? Which one?
The one that's the vertical one.
So is that A, B, or C?
That's A.
A. A is 40 degrees. Because it's a vertical angle. Okay. How would we then figure out what B and C is? Yes. These add up to 180. So I can go 180 minus 40. That gives me 140 degrees because they are supplementary, but they are also a linear pair. Okay? So what would C be? If B is 140, C is also 140 because they are vertical angles. So that's what you'll have on your homework for tonight, is things like that. Okay, so I am going to stop recording, but I'm going to leave this up here.